Okay, in concern of our fourth semester practicals, we have one more practical, that means synthesis of benzimidazole from ortho-phenylene diamine. So we'll see today now what is the procedure for the synthesis of benzimidazole from ortho-phenylene diamine. So in this one, we will take this under microwave-assisted reaction conditions. Normally, we do carry out these reactions conventionally. That means we do heat that things. That means we added all those starting materials in round bottom flask, and we do heat that one on oil bath or water bath. So now we will apply microwave radiations to convert this orthophylline diamine to benzimidazole. We'll see now the how to do that one. So our starting materials is orthophylline diamine plus any aldehyde, substituted aldehyde you can take, and with the help of microwave radiations we can do synthesis of this microwave benzimidazole synthesis. So we know the theoretical part, we have finished the theoretical part. So mechanism we know very well, how to what is the mechanism, what is happening. So we have already these two nitrogen atom which is present in the benzene ring, and we needed only one carbon atom to complete our imidazole ring. So this one is benzimidazole ring we completed over here. And now here we need to add some catalyst. Okay, any catalyst we need to add. So we will finalize what which catalyst we will add, whether we have a lot of options. So what options we have, we will see now. First we will see the introduction of benzimidazole derivative. Introduction of benzimidazole derivative, we can say. So benzimidazole has widespread of different applications. So it acts as anti-tumor agent, antivirus, and anti-allergic, antimicrobial, antihypertensive, etc. Okay, so several compounds having ligands, we can use them as an ligand in asymmetric catalysis. That means we have seen already, that means in ruthenium catalyze, and in short transition metal catalyze all these reactions like carbon carbon coupling reactions, or olefination metathesis reactions. In order to achieve some complicated reactions, we use chiral ligands on that transition metals. So in some of those chiral catalysts also you can find benzimidazole is added as an in form of carbene. We have done these reactions. That means we have made this catalyst for the asymmetric induction. Okay, so in short, this benzimidazole is very important for different purposes. Okay, what is the catalyst scope for the this micro assisted benzimidazole? This is what type of different catalysts we can use. So this information I have got from one paper research article. I will give you that reference from which research article I have collected all this data. So we need a benzimidazole synthesis, different catalysts we can use. So here one for benzophenone we can use for it as an oxidative agent. Manganese dioxide we can use. Hydrogen peroxide plus HCl we can use. Then benzopyroxene we can use. Then DDQ we can use. Seric ammonium nitrate we can use. Sodium bisulfate. So out of that one, we have in our laboratory seric ammonium nitrate. We have plenty of seric ammonium nitrate, and we can also use DDQ. Manganese dioxide also is easily available. So we can try any of that catalyst and we can conduct this benzimidazole synthesis. So reference for this synthesis of benzimidazole is Green Chemist Letters and Reviews 2017 published paper volume 10 issue 3. So this microwave assisted practical and simple method for heterocyclization of ortho-phenylene diamine and aldehydes using DDQ as an oxidizing agent, reported by Hossein Naimi and Zahra Babil. Okay, so this is the reference for that one. What is the procedure for the synthesis? So how much amounts we have to take, starting materials, what amount of we have to take. So solution of orthophenyl diamine, that one we have to take 1 millimole, and aldehyde, that means also 1 millimole. And in a minimum amount of acrylonitrile was prepared. Okay, so small amount of acrylonitrile, acetonitrile we can use, not acrylonitrile, sorry. So solvent we have to use as acetonitrile. So DDQ catalyst 0.14 gram we do add 60 mole percent into the Hermé flask, and this mixture we will irradiate in a microwave oven. pay attention whenever you will carry out the microwave assisted reactions. You have to conduct all these reactions in aprotic solvents. Okay, so acetonitrile is a protic solvent. So we can't use protic solvent, we have to use a protic solvent. So after when you read this in microwave oven, the progress of the reaction is monitored by TLC. After completion of the this one reaction, once you finalize your reaction is completed on TLC, you can pour this mixture, or you can add drop wise. This mixture of ice reaction was added drop wise into a mixture of ice and water. Then you can pour this one on ice water. So you will get your precipitate in your product in form of precipitate. Filter that one and you will obtain your precipitate. You can recrystallize it from ethanol water 1:1 solution, and go for the melting point TLC and everything. So spectroscopic data today I will give you some. Once if we will synthesize in the laboratory all these things, uh, for example in case of procedures, sorry, in case of project, once you get your final product in your hand, it should be pure actually, and then you can go for the NMR and C13 data. So this is scanned C13 data, or sorry, proton NMR data for this benzimidazole. Okay, so it's very clean proton NMR data is here. So whenever you will conduct your project, at that time your spectral data should be in this form. It should be very clear. So we'll see one C13 NMR. Okay, it is also very clean. No impurities at all in this one also. Okay, so these are the thing, and you have to write your observations or your readings in the result table, so you know how to write the result table. So in this way we will stop here, and we'll finish this one benzimidazole synthesis.